Namaskara. Welcome to AI Bits N Bytes from Vigyanlabs. I'd like to introduce Mr. Srinivas Varadarajan, co-founder of Vigyanlabs. Sir, welcome to this first episode.
Thank you.
Yeah. So each series will be played for all the audiences in bits.
Yeah.
So first, let us introduce Vigyanlabs. Can you please give an introduction to Vigyanlabs and as well as introduce yourself?
See, we are a deep tech company based out of Mysuru. So we are into AI, cloud, and data center, right? So we're a deep tech company which has built the complete stack indigenously, the AI stack, the cloud stack, and the physical data center infrastructure. And so Vigyanlabs, has pioneered some of the deep tech innovations in the AI space and the data center space, and focus on how do you create AI infrastructure which is sustainable and very cost effective to large population in India and rest of the world which don't have access to the AI infrastructure. Coming back to myself, right? I did my engineering at SJC Mysuru, did my masters at IIT Mumbai. I worked in large number of global corporations, Hughes Network Systems, then Hewlett Packard, Dell Services, and later Vigyanlabs. Then one of the couple of critical projects we did at Vigyanlabs in the inception stage was about Aadhar, myself and colleague Vatsa, few of the colleagues from Vigyanlabs. So I was the principal architect, Vatsa was the application architect. So we did the initial architecture design, data center design, architecture, technology architecture, procurement, pilots, onboarding. So the entire framework we built for Aadhar. And subsequently is Aadhar phase 1, we also did the work on phase 2. And we also did a couple of nationality projects in other countries like Philippines, Morocco, Togo, and many more. And the learnings from all these projects, large projects, helped us to build a data center which is a state of the art, which is Mysuru, which does not consume any water, uses solar energy, and has a very small footprint. And what we call it a micro data center. Our innovation in the whole space is about micro data. How do you create small sustainable data centers which is self-powered, does not only consume any water, but can deliver reliable, secure AI and digital services to could be enterprises, could be the common man, right? At a price point which is fairly affordable.
Yes, thank you, sir. Sir, setting the context, now everybody is talking about sovereign infrastructure development, or SID in short. And we would like to know from you, what is the sovereign infrastructure context with respect to India and why it is so important in this current time?
See, if we just look at, what's happening in the world, right? Data has become critical. What is important about AI, right? All about AI is, okay, you're creating a model, training a model. To train a model, you need data. And what's happened, the big AI models have been built last couple of years, right? With publicly available data. As you build more and more AI models, it needs data. Where is the data going to come from? Your personal data, or your organizational data, or enterprise data.
Correct.
And once models are created, what's going to happen? There's going to impact on your privacy. Because the public model, right? Anybody can, a model is trained on your personal data. Anybody else who can use the model will get your data, right? Directly or indirectly, right? A model. So what's important to protect personal privacy, organizational privacy, and IP, right? Today, every organization has its own IT systems.
Yeah.
IT systems, your IP, right? You have your own processes, pathology, your IP is your IP, right? In addition to other innovations you have, right? So it's important that as we build AI systems, what are the AI doing? It abstracting the organization or individual knowledge, abstracting it, make it available in a different way, right? So if your organizational knowledge should be yours, right? What's your USP today? If your organizational knowledge is moved to a large ecosystem of a large AI model, all the organization's knowledge is moved there, and the model is trained. What is the differentiation between organization A, B, and C? All look same, right? So it's important that every organization understands that their models and the data within themselves, because that's a USP. So what do they do? What do we need to do? Enable organizations to create their own AI models, train their data, train with their data, and create a personalized or hyper-personalized AI infrastructure for every organization, which is unique to them. And as we go forward, this critical not only for an individual level, an organizational or country level, right? Because today, as we saw, the future wars will be for digital wars. So by denying access to data can cripple economy, right? Today, we have seen that where the social media, where the internet today, the data So you can cripple any economy. So future wars will be digital wars. And I would say not just India, every country should have its own production mechanism to safeguard its data and sovereignty of data. And finally, it's about AI, right? Have its own AI built sovereign AI systems, train for its data, and train for its own local enterprise and citizens. Right?
Okay. Sir, actually, I also answered my next question. So I'd like to go to the third question in this series. Like, what is the significance of building an sovereign infrastructure, and especially in country like in India? And since you already have built a green data center by yourself, uh, right from power management to AC, cooling, and the entire civil construction, mechanical part of it, electrical part of it. How do you see the transformation goal need to be set for India so that we see that earlier data was sitting on premises, then slowly it moved to cloud. 20-25 years back, it started moving to cloud. Now most of the people are coming back to have their own cloud in their own setup. So how do you see this transformation happening in India?
I think, see, the technology comes in cycles, right? If you look back historically, we had mainframes once upon a time. Mainframes very powerful. Then came the PC world, right? PC revolution happened in the early 90s, right? Late 80s and the 90s, PC revolution happened. Over time, PCs become very powerful. And networking also became affordable, right? And high-speed network, internet came in. So we moved to distributed computing. Okay, so we moved from a centralized computing to distributed computing. Again, what happened, while the PC lagged a little behind, the cloud, gave the convenience, right? Small organization, enterprise who wanted, capacity on demand. Cloud became an alternative. You can scale up quickly without having capacity. Became, and then cloud has become a central infrastructure. But as we see the evolution of computing infrastructure last couple of years, right? It's important to recognize the technology changes, right? We're getting more and more powerful GPUs, right? GPUs and the computing infrastructure is going to become powerful. When the computing infrastructure becomes more powerful, probably we'll keep it, right? And it's time to have a model where you keep some of the infrastructure within your enterprise, as long as it's affordable. It's affordable. Business makes sense, right? If you can have capacity. Look at today, over cloud was great for on-demand and peak loads, but a large number of organizations, except for e-commerce works, they have very much predictable load, and there's spikes once in a while. So and people have seen that cloud costs, although promised to be much lower than keeping on-prem, it has over time ballooned. So enterprises are beginning to realize that, yes, I'll keep cloud for certain workloads which is internal, which is static, don't change. I want to keep it on-prem. And today to have a model where on-prem is also feasible, right? Today, if you look at globally, the IT world, so we all say the cloud, right? The global IT spend is almost $3.5 trillion. It's coming to $4 trillion per year, which cloud is only 600 billion. So a large part of the IT infrastructure is still on-prem, which you recognize, and which will probably continue to remain on-prem. So people will evolve a model, what's good for cloud, what is good for on-prem.
Okay.
And Vigyanlabs, our endeavor has been to look at a country like India and many other countries where energy is an important factor. So look at today, what are the natural resources required to run a data center, right? You need energy, you need land, you need water. And we try to see how do we minimize all these three things, right? One is water. We try to eliminate water because water is a scarce commodity. In a country of 1.3 billion population, we have seen droughts coming in, and water is a typical data center, right? For cooling, evaporative cooling, you consume about 2 liters of water per kilowatt of energy consumed, which is a very large number.
That is pure water.
Pure water, because it's you need the chiller, right? You use evaporating cooling. Of course, the people talk about liquid cooling. Still a long way to go to make it affordable and sustainable. Second is land, right? How do we minimize the land? So why do you want to use prime agricultural land? Use land which is barren land, right? We have country which blessed with plenty of solar energy, right? Almost 300 days in a year you have gray, blue skies and plenty of sunlight. Why can't you use the natural resources? Power data centers. And how do you do that? So what I've been at Vigyanlabs, we have worked about last 4-5 years to actually create a model where you can create a sustainable data center. What I call as a micro data center. It can be small. Small doesn't mean it cannot do many things, right? Small means uses very little amount of natural resources. Zero water, a small piece of land, use plenty of sunlight what's available, and use grid as a backup when required. And what we demonstrated is that but a small data center, a micro data center, about less than 100 racks, few hundred kilowatts of power, we're able to run AI workloads, general computing workloads in a large scale, and that's what the model we want to help organizations adopt.
So you have busted the myth saying that data center doesn't need megawatt; it can run in kilowatts.
Can build a lot of, see, the distributed one makes sense because what's happening as a country, look at it, almost 60 to 70% today energy is from fossil fuels.
Correct.
Although we are transitional solar and renewable energy, hydro, we still have a small percentage of hydro, solar and wind. So the energy mix is still very high fossil fuels. And today energy is distributed. So okay, look at today, what is the rooftop solar, right? Rooftop solar is allowing you to create a distributed energy generation, right? Energy generation can be distributed. Why can't computing be distributed, right? Simple,
Correct.
Right? It doesn't make sense to set up a large coal plant, in a gigawatt hour coal plant somewhere else, and then wheel the energy the other side of the end. Just huge amount of, we need a lot of time and investment into building the transmission and distributed infrastructure.
Plus
It's
losses.
expensive. There'll be losses. I mean, of course, losses can fix over time, but it goes a lot of time and money is better. So why can't we distribute it, right? We have demonstrated that we can build sustainable, highly powerful data centers, which works, right? Just like PCs, right?
Correct.
PCs challenge the myth that thousands of PCs can do a fairly good job, right? And with distributed computing technology, we look at distributed training, all the technology in work. We are of the opinion that yes, you need the big ones and smaller ones, right? Let's look at example. I give you in the industry like airline industry. Right? There are large airlines, right? Which runs international. There are also feeder airlines.
Correct.
You need both, right?
So it's like more like edge computing. There's more of an edge data center.
So you need edge data center because there are a lot of use cases like video analytics, self-driving vehicles, sensors data, and then IoT Industry 4.0. All of them require latency in milliseconds.
Correct.
And more such use cases are going to come, right? Already we have seen, right?
Real time.
There's large number of real time applications with drones, surveillance, traffic signaling. A lot of things are where you want to use AI. You can't go back to a data center which is far away, which requires seconds latency. You need millisecond latency. I say 1 or 2 milliseconds. And 6G coming in, I think there's a perfect marriage between edge and 6G, right? What are the use cases for 6G? AI edge workloads are the perfect use case for 6G, right?
Correct. So with this, now we understand, fairly understand with your explanation as to how to build a data center grounds up. But not only building the physical structure, but you also need to build the digital structure.
Yeah.
So how do you architect and orchestrate the whole thing? What is your approach towards this so that it is more sustainable and also it's a sovereign approach what we are trying to take? So what would you say to the users?
Basically, the data center is two parts: the physical infrastructure, right? Physical infrastructure is building. We have demonstrated that we can create a sustainable building using 70% less cement, right? It's less cement, and you can use the entire rooftop as solar energy generation.
Correct.
But you also have battery storage technology, which is fairly mature today and it's reasonably affordable. So you can actually battery storage. What do you do at the night times when the bad weather? Of course, you need to have a backup power to run the data center. But with the battery technology, you can use battery storage and run 24 hours, right? That's possible. Second is the electrical part, right? Electrical infrastructure, and the cooling infrastructure. So we have created a technology where we can actually make the cooling, use natural cooling, right? Air cooling or natural cooling to make the, reduce the PUE to almost less than 1.3.
1.3.
Less than 1.3, we can be able to run that and demonstrate that. And then that requires a lot of optimization. Again, we use AI, right? Because we are looking at providing AI infrastructure. One of the things concerns me is that if you want to provide AI service, is your data center AI enabled?
Okay.
So we have demonstrated that we can actually create a data center grounds up, which use AI to make everything sustainable. So the biggest breakthrough we achieved is using AI to run all our operations, electrical systems, cooling, IT operations. The moment you use AI, it makes your life easier, it automates a lot of things and makes things more efficient. So we demonstrate that AI, the power of AI, how AI can make a data center very, very highly efficient in terms of reliability, sustainability, and of course, high performance, right?
So that is your first use case. Use AI to run a data center.
Yeah.
Which in turn runs AI load.
AI workload, yes.
Okay. So it is a cyclic dependency is there.
Yeah.
And now since we build this huge storage capacity and compute and the configurations of the servers are also increasing day by day, how do you define at the software level? How do you attend to all the requirements which comes in a very short notice, and how do you handle this request?
So basically we looked at orchestration. We did orchestration. So you build a bunch of computers, right? High-end servers, right? Today you see that You already have 128 core. Soon you'll get a 26 core server chips, right? So you got highly high density equipment. You also can actually today you can go to terabytes of RAM in a server, and you can interconnect them through a what you say spine leaf architecture, high speed backbone, right? You can go to hundreds of gigabytes of backbone, interconnect them. Then one is the compute part. Then compute with GPU, right? You can always put in each box, each server you can put probably petaflops of GPU computing power. That's one high speed backbone. Then you have software, right? What is software? You can combine a bunch of this high speed again NVMe and enterprise gate disk. Combine them, blocks, building blocks, and put a software, what you call a software defined storage, which appears as a block file or a object storage to the applications. And you virtualize the infrastructure, right? You use virtualization, virtualize the infrastructure, the storage, network, and compute virtualize, and you allow enable containers to run AI workloads, right? AI ops, ML ops. So basically, we need an orchestration layer which ties everything together, which provisions the compute capacity based on the workload of the user. Automatically compute could be GPU, could be storage, or could be high level service, right? IaaS services, passive AML service. You need what do you need? You need microservices, you need containers to run, you need databases to run, you need messaging systems to run, you need databases, data stores. So all this can be controlled by orchestration layer, which can provide and instantly